All right, so far in this chapter, we've learned about really three important types of angles: complementary angles, supplementary angles, and then from our previous section, vertical angles. Adjacent angles just mean angles that share a side. They're not really important unless together they're complementary angles, or maybe both those angles would be supplementary. So these are really the three important ones. And so we have a picture here, and it wants us to name two pairs of complementary angles, supplementary angles, and then vertical angles. So we'll start with the complementary angles. I'm looking for two pairs that would form 90-degree angles. And so I see a lot of different pairs because this is a rectangle. And because it's a rectangle, it's got 90-degree corners. And so angle 1 and 2 would have to add up. So angle 1 plus angle 2 would have to add up to be 90 degrees. And then another pair, we could say 3 and 4. Angle 3 and angle 4 would have to be supplementary. You could also say 8 and 7 and 5 and 6. Next up, two pairs of supplementary angles. These angles have to add to 180 degrees. So instead of forming a right angle like the ones from up here did, we're looking for two angles that form a straight angle. And so we have some of those angles as well. And so I would say, 10 and 11 would be supplementary angles because they form this straight angle right there. So I'd say angle 10 and angle 11. And then also angle 9 and angle 12 would be supplementary because they form a straight angle right on the other side of that purple line that I drew. So together they form 180 degrees. If I were to draw my line this way, then I would say angle 9 and angle 10, and then angle 11 and angle 12 would be supplementary. So there's quite a few pairs of supplementary angles up there. And then next up it says vertical angles. So for vertical angles, let me get rid of this. For vertical angles, I'm looking for two angles that are opposite from one another. This is our vocab word from last section. And so let me go ahead. I'm going to draw these straight lines again. Here's our intersecting lines. And so vertical angles, I could say angle 10 and angle 12 are vertical from each other. And then angle 9, this angle here, and angle 11 are opposite from one another. So angle 9 and angle 11 are vertical angles. All right, so this next part, we're going to tell whether the angles are complementary and supplementary, and then we're going to find the value of x, just like we did on the previous homework, actually, where we were using math or algebra to solve. And so these two angles together, this angle and this angle, form a right angle. I can tell that because of the little right angle box right there. So I know that they are going to be complementary angles. And remember, we can abbreviate that. And so that means together they will add up to be 90 degrees. So the 4x angle plus the 36-degree angle has to add up to be 90. And from here, I can just solve. We can subtract 36 from both sides. 90 minus 30 is 60, and then if I subtract 6 more, that's going to give me 54. Make a 4 there. Equals 4x. And then we can divide by 4 on both sides. This is just a two-step equation, so my first step is subtracting. My second step here is dividing. And so 54 divided by 4. Remember, you can use your calculator for this, and when you do that, we're going to get 13.5 for the value of x. So again, to recap, I know they're complementary because they make a 90-degree angle. I add those two angles together and set it equal to 90 to make this equation. And so that equation step is super important because without this equation, you're probably not going to be able to get that 13.5. But once I set up this equation, it's really easy for me to solve it and get 13.5 for x. All right, this next one, I've got two angles that together are forming a straight line. And so that means 180 degrees. So that means these angles have to be supplementary. And so because they're supplementary, I know together that they'll add up to be 180. So 4x plus 5, the first angle, plus the second angle, 41, has to add up to 180. And so here I've got some terms on that left side that I can combine. I've got a 5, and I've got a 41 that I can combine. That's going to make 46. So 4x plus 46 equals 180. And then I can subtract that 46 from both sides. That's going to give us 134. And then just like the last problem, we end up with that 4x, so we just divide by. So we're going to divide by 4 and divide by 4. And again, using my calculator for that, I'm going to get x equal to 33.5. So getting some decimal answers here. Okay, and if you're not ever sure about that, try plugging it back in for x, right? I could just very easily do that. So 33.5 times 4, if I plug that in, would make 134, and then add 5 to that, and I got 139. If you add 139 with 41, we get 180, so we know this is true. All right, next up, example C, we again have two angles that are forming a straight line. So 180 degrees, which means these are going to be supplementary angles. And so I can make an equation that looks like this: x plus, so this angle, plus this angle, x plus x minus 4, has to add up to 180. And so just like in the last problem, I've got some terms I can combine here. I've got an x and an x, and together that's just going to make 2x. And then we just drop down that minus 4 equals 180. And then to get rid of the minus 4, we're going to add 4 to both sides, which will give us 184. So 2x equals 184. And then I divide by 2. And so 184, let me go ahead and write this down, divided by 2 is going to be 92. So x equals 92. And now I have my value for x. That one wasn't a decimal. Again, I can double check by putting 92 up here for x, and then 92 minus 4 would be 88. And if I add those two angles together, I'll get 180, so I know it's true. All right, and this last one here, I've got, again, a right angle. So these two angles are forming a right angle, making these complementary angles. And so I'm going to add them together. X plus the 2x minus 3 angle has to add up to be 90. And so again, I'm going to combine my like terms. I can combine my variable terms together. X and 2x just makes 3x, because that's a 1x right there. Remember, this is 1x plus 2x is 3x. Minus 3 equals 90. We can then add 3 to both sides to get rid of the negative 3. And that's going to make it 3x equals 93. And then finally, I can divide by 3. And so 3 will go into 90 30 times. It will go into 3 once. So x is going to be 31 for our value of x. And then, of course, I could always plug that in to double check. 31 degrees. This would be 62 minus 3, which is 59 degrees. And so 31 degrees and 59 degrees does add up to make 90. So I can double check my math when I'm done, just like I can do with all equations. All right, number 22 on the homework says, which angles can be supplementary when paired with another angle, but could not be complementary when paired with another angle? So I'm looking for angles that could add up to 180, but couldn't add up to 90 if you pair it with another angle. And so in order for this to be true, you know, like 89 could add up to be 90, 15 and 50 could both add up to be 90. In order for this to be true, I have to eliminate the angles that are smaller than 90 degrees. Because if I add 1, I could make that complementary with another angle. If I add 40, I can make it complementary. And if I add, well, let's see, what was this again? 15. So if I added 75 with that angle, I could make it complementary. But that's what I don't want. I don't want to be able to add with another angle to make it complementary. So I'm going to eliminate all these, leaving me with these options over here. I could make this angle supplementary if I added it with 75. I could make this angle supplementary if I added it with 6 degrees. So again, I was eliminating the purple ones because they were smaller than 90, which means they could have been complementary with another angle. I was just looking for ones that could be supplementary but not complementary. So I'm looking for ones that are over 90 degrees that I could make, still add to 180, so they're supplementary. Number 23 says the vanishing point of a picture is represented by point B, the measure of angle ABD. ABD, I better mark that so I know which one that is. ABD, A to B to D, this angle here, is 6.2 times greater than the measure of angle CBD. CBD is this one right here, C to B to D. Wants me to find the measure of angle CBD. So I know that together, these two angles, the red one that I drew and the purple one that I drew, are supplementary. I know that because they sit on a straight angle. Angle ABC is a straight line. So together, they'll form that straight 180-degree angle. So I know that the red angle plus the purple angle has to be 180 degrees. So I'm going to use the fact that the red angle is 6.2 times greater. So let's assume the purple angle is just x. If the red angle is 6.2 times greater than that, I would say the red angle is 6.2x. And because they're supplementary, that means when I add them together, I should get 180 degrees. So let's do a little bit of algebra here. If I add 6.2x with 1x, that's going to give me 7.2x equals 180 degrees. And so using my calculator, I just divide 180 by 7.2. That's actually going to give us a nice number here. X equals 25 degrees. So since this was x and this was 6.2x out here in red, and I just want to know what this angle is, the purple angle, then I know since x is 25, that purple angle is 125 degrees. Part B says angle FBE, so now I'm going to erase, whoops, that's not my eraser. Now I'm going to erase and see if I can get rid of this so we can see these two new angles. Angle FBE, F to B to E, okay, and angle EBD, so this angle says these angles are congruent. They are the exact same size. The measure of angle FBE is what? So FBE is this one. I want to know what that is. So because that angle is congruent with this angle, that means if I find out what angle EBD is, I'll know what angle FBE is. And so I already know that this angle, which I did in the previous problem, is 25 degrees. And you may not have noticed this, that's a right angle right there. So this is a right angle. So this angle here that I'm coloring purple and the 25-degree angle are complementary. They make a right angle. So I know that x plus 25 has to make that 90-degree angle. So I'm going to find out what this x is, and once I know what that x is, I'll know what this x is because they're the same. So if I subtract 25, subtracting 20 gives me 70, subtracting 5 more gives me 65. X equals 65 degrees, and so if this is 65 degrees, so is angle FBE, 65 degrees. So I actually use complementary and supplementary angles to solve both parts of this problem. Number 24, your friend says angle LMN, this angle here, whoops, that's off a little bit. Let's try that again. LMN and angle PMQ are complementary angles, meaning they would add up to be 90 degrees. Is she correct? Well, let's notice a couple things here. First of all, those two angles sit on this straight 180-degree line. So we'll call it angle 1 and angle 2, just so I don't have to keep saying those letters. Angle 1 and angle 2 sit on that straight, but they also sit on that line with angle, we'll call it 3. Well, here's what I know about angle 3. Angle 3 is 90 degrees. So if I take that straight angle and subtract away angle 3, that means there's 90 degrees left for angle 1 and angle 2. And if angle 1 and angle 2 are going to add up to be 90, they are for sure complementary angles. So our friend is correct here. And again, the reasoning is because the angle in the middle is 90 degrees. So if you subtract away that angle, 180 minus 90 leaves 90 degrees left for angle 1 and angle 2. So she's correct. They are complementary angles. Number 25, this is one similar to the vanishing point problem. It says the measure of two complementary angles, come back to that, has a ratio of 3 to 2. What is the measure of the larger angle? So I don't know what the measure of either of the angles are, so I'm going to put X down for both of them. But I do know that one of the angles has a ratio of 3, the other one has a ratio of 2. So one of the angles will be 3x, and the other angle will be 2x. Now, because they're complementary angles, I know that together they will add to be 90 degrees. So now I have an equation, 3x plus 2x equals 90, that we can solve for. And so if we combine our like terms, 3x and 2x makes 5x. And 90 divided by 5 is 18. So x has to be 18. But it does say what's the measure of the larger angle. It doesn't ask us what x is. So the larger angle is either the 3x angle or the 2x angle. Well, obviously it's the 3x angle would be the larger one. So if x is 18, then I just need to know what 3 times 18 is. And that is 54 degrees. So the larger angle is 54 degrees, and then obviously we'd find out what the smaller angle is by subtracting from 90. But we don't need to do that. Number 26, two angles are vertical angles. If the angles are also complementary, what would the measure of each of them be? Well, if they're vertical angles, that means one important fact. That means they're congruent, which means they are the same size. They have equal measure. So if two angles are the same size and they add up to be 90 degrees, well, then I just take 90 divided by 2. That means both of them have to be 45 degrees. That was actually pretty easy for that one. And then it wants us to know if the angles are supplementary angles, what would the measure of each of them be? Well, if they're supplementary, that means they add to 180. And since they're both the same size, if I divide by 2, each of those angles would have to be 90 degrees.